Alright, so we are looking at Chapter 9 in your textbook, Stoichiometry. I'm going to be going through a couple of sample questions, and I would like you to attempt a couple of practice questions on your own. They will be very similar to the sample questions we go through, and just make sure you watch the video and look at that before I see you next, which will be sometime next week. Alright, so we are looking at the chemical reaction between nitrogen, N2, and hydrogen forming NH3, which is ammonia. Alright, so we have one nitrogen molecule and three hydrogen molecules forming two ammonia molecules. Okay, that is the balanced chemical reaction. The N2 and the H2, nitrogen and hydrogen, they are both diatomic molecules. So just keep that in mind. There are 2 atoms per 1 molecule. But in the balanced chemical reaction, their coefficients are 1 for the nitrogen and 3 for the hydrogen. And the result of this synthesis reaction is 2 ammonia molecules. And our question is, how many moles of hydrogen are needed to prepare 738 moles of ammonia? So if you want to pause here for a second and work out the question because you think you have it down, go for that. The hint that I will give you, and I'll be showing you this in a second, is the mole ratio. That's the key. All right, so think about the mole ratio to solve this question. Give it a shot on your own. Alright, so it's important to think about what we are given and what we're being asked to find. So in this question, we were given 738 moles of NH3. Alright, 738 moles of ammonia. And let's remember, a mole is 6.022 times 10 to the 23rd individual molecules of ammonia. So that means we have 738 times that number 6.022 times 10 to the 23rd individual molecules of ammonia. So that's a lot of molecules. So we're going to need a lot of hydrogen molecules to make all of that ammonia. Now, the ratio that we can see from the coefficients of the balanced chemical equation are, for every 3 moles of H2, we can make 2 moles of NH3. All right. So here's the moment where chemistry kind of goes off the rails, and you'll hear people complain because I'm writing 3 equals 2, and mathematically that's just not sound, but it works when we think about our molar ratios, our coefficients in the chemical reaction. I would suggest thinking about a chemical reaction as a recipe, and there's lots of ingredients involved, but we're only focusing on 2. We're focusing on ammonia and we're focusing on hydrogen. We're going to disregard that N2 nitrogen molecule because based on the way the question's phrased, we're just going to assume it's an excess and however much we need, it will be there. All right, so if we take 3 moles of hydrogen, 3 moles of hydrogen molecules, we're going to make 2 moles of ammonia molecules. So I know you're probably thinking 3 doesn't equal 2, but for chemistry, for stoichiometry, 3 moles of hydrogen equals 2 moles of NH3. All right. It's important to remember we're not working with exact numbers. We are working with amounts of chemicals, okay, chemical quantities. So that's why we can get away with that as long as we write 3 moles H2 and 2 moles NH3. If we didn't write the moles in each part, it would make no sense. Writing the numbers 3 equals 2 doesn't make sense. But when you include the moles H2 and moles NH3 and you look at the chemical reaction we're given, then it does make sense. So done ranting about why chemistry doesn't make sense, but actually it does make sense because just think about it. It makes sense. Like it just makes sense. So that's what it does. It makes sense. So sorry for a long rant. All right. So the math we're going to do is 738 moles of ammonia times the mole ratio. So the mole ratio is always going to be a fraction, and what you're going to put is the coefficient of what you are looking to find on the top of the fraction, and the coefficient for whichever reactant or product you are given on the bottom. So we're going to do 738 moles of ammonia times 3 moles of hydrogen divided by 2 moles of NH3. All right, 2 moles of ammonia. Now, in that previous segment, I went on an entire rant about how 3 moles of H2 equals 2 moles of NH3. So since they're equal to each other, when I divide them, it's just going to equal 1. All right, that's the mathematical sense of what's going on. We're just multiplying by 1. So that's why we can put it into a conversion bridge so easily, because each piece of a conversion bridge is equal to 1. But I kind of want to track my units here. All right, so I'm going to do moles NH3 times moles H2 divided by moles NH3. So if anything is exactly the same on top and on bottom, we can get rid of it. All right, it'd be like having x divided by x in your math class. You would just get rid of them, it would be equal to 1. So imagine if you had x times y divided by x. You would get rid of those x's, your answer would just be y. That would be simplifying your answer in math class. So we're doing the same type of math here in chemistry. So when I use a calculator, 738 times 3 divided by 2 equals 1,107 moles of hydrogen. All right, so a pretty simple question. We have found moles of hydrogen. That's what we were asked to find in the question. That's what we put next to find when we identified what was given and what to look for. So that should let us know it's time to stop. A lot of kids make mistakes in stoichiometry because they just do random things because they don't know when to stop. All right, so it's important to identify what you want to find early in the question, and once you find it, just stop. All right, that will help you avoid making any frivolous mistakes. If you are curious about significant figures, because that's something on your mind, since we were given 738, that would be 3 significant figures. The 3 and the 2 coefficients, those won't count as significant figures because those aren't actual measurements. Those are exact numbers based on our whole number coefficients because we don't use fractions when we balance chemical equations. So what we would round to is 3 significant figures. So it would be 1,110 moles of hydrogen. Not trying to freak you out. You do not need to worry about significant figures for any quizzes or tests that we're going to take in this unit. But it is something to keep in the back of your mind for next year if you take AP Physics. So sig figs will be important next year. This year, not as much. We just did one stoichiometry question. If you look in the textbook on page 304, you will see this exact same sample question, just with different numbers. You can go through that as well. All right, so try the upcoming question by yourself. This will be a homework question. Have the answer for class. I'll put that question up in a second. So do question 21 on page 329, parts A, B, and C. These are using mole ratios, so you're going from mole to mole, just like the practice question we just did.